All right, we are back with part B. We're going to go through the last slides. This should be a little shorter. Here we go. You're going to find the percent in between regions of the bell-shaped curve using technology. So going back before, let's go back to this on the left side. If you were doing this by hand, you would be thinking about this. There are two different places that are going to be on the bell-shaped curve, 224 and 225. You would want to find the z-score for both those. So 224 minus 224.2, you're going to divide it by 0.7 standard deviation. You're going to get this z-score. And then for the 225, you subtract again the mean, you divide by standard deviation, you're going to get 1.14 for that z-score. So if you go to the tables with these two z-scores, you're going to get 0.3859. And then for the 1.14 z-score, you're going to get 0.8729. Now on the graph, this is what it looks like. So if this is your first z-score, that means you should have a 0.3859. You should have that much percent of the curve to the left of that first line. And for the second line, the second marker right here, you're going to have a 0.8729. So definitely a bigger percentage because you got more of the bell-shaped curve. So again, I've got basically a 38% chance of being to the left of the first one. I've got an 87% chance of being to the left of the second one. But if you really want the region that's between these two, what you're going to do is take the bigger region, you're going to subtract the smaller region, and then that is going to leave you the region in the middle. So in this case, it'd be 0.487, aka 48.7%. Okay, that's what's going to be in the middle. Now using technology, it's a little more slick. So check this out. If you're going with the z-score look here, the standardized look, think about it. The negative 0.29 z is going to be the lower boundary. The 1.14 z is going to be the upper boundary. So you plug those in just as they are, lower and upper boundary, a mean 0, standard deviation 1, hit the paste, and it's going to take it down here, and this is going to be your answer, 0.4869, which is definitely very close to what we got. If you want to go straight up with the numbers, here's what's going to look like. If you plug in 224 for the lower boundary, 225 for the upper boundary, because that's what they're going to be. You got 224 over here, you got 225 if you're talking miles per hour. The mean would have been 224.2 miles an hour. The standard deviation is 0.7. And paste that and look at your answer. You're going to be right there in the same ballpark. Okay? So again, three different ways you can look at it. So now think about this. This is going for the region in between. On the next slide, they're going to ask you for how to get the region on the outside. So basically, what I'll tell my students is just to keep it simple. Think about it. Go ahead and find the region that's on the inside, which we just found was like 48.7%, right? And if you want to get the area that's on the outside of that, just find the difference between that and 100. If you're doing the decimal, you just subtract 1 minus 0.487. If you're doing the percents, just do 100 minus 48.7%. But you're going to get something like 51.3. So that represents all of this area that's going to be outside of the middle. So it's kind of like the last problem. You're just going to go one more step further and just find the difference between that and 100. Okay, so those aren't too bad at all. So again, the big thing is just make sure you're reading the question and make sure you're picking up, the lingo, where you're going. So where would you expect your speed to be outside of that interval? So definitely outside of that window. So we want out here. All right, that's it. I hope this serves you well. I hope you're doing well out there, y'all. Good luck.